So, lecture 1.12. This is the last section for chapter 1. Huzzah! Okay, so here we are, we're working with variations. So a few different ways that we can look with variation. We have direct variation. So y varies directly as x. So for example, maybe the more sugar you eat, the more weight you gain. That would be a direct variation. Or maybe the more you read, the more you know. So they're both going up. So direct variation would look like y equals, and this is our constant of variation, times x. So this would be read as y is directly proportional to x. Okay, so whenever you see y is directly proportional, you write y is, and then you just plop in that constant of variation, and then your x value. Or sometimes you might say y is proportional to x, or also you might say y varies directly. So either directly or proportional is normally the words we use for direct variation. Then we looked at inverse variation. So y varies inversely as x. So maybe the more you work out, the less you weigh, or maybe the more you diet, the less you weigh. So that would be maybe an example of an inverse variation. So here's our equation. Y is inversely proportional to x. So y is, and then there's our constant of variation k, and then you have the inverse proportion of x. Okay, so two different options, direct and inverse. And then we have the joint one, which means we can tack on as many direct and inverse variations as we want. So z varies jointly as x and y. We'd write it as z, plop in that constant of variation. Z is jointly proportional to x and y. All right, let's look at an example and try to create one of these. Write an equation for the statement. P is proportional to the square of Q and inversely proportional to R. So I have two different things. I've got proportional to the square root of Q and then inversely proportional to R. Okay, so whenever I see P is, remember is the word for equals in math. So P is, and once we do the equal sign, immediately just plop down K, your constant of variation. Always do that. Something is, boom, constant of variation. Then what happens? Proportional to the square of Q. Okay, proportional, remember that's another way of saying direct variation. So proportional, so directly. And the square of Q is going to be Q squared. And inversely proportional to R. So we're going to take the inverse of R. And there we go, we have an equation. So we could simplify this if we want to P equals KQ squared all over R. Either one would work. All right, let's look at example 2. Write an equation of the statement. Go ahead, pause and see if you can write this equation, and then check in with me in a second. All right, let's see. So we have A is jointly. Ooh, jointly? Okay, so that means we're going to have more than one. So A is, and immediately after I do is, what happens? We plop that constant of variation down. So it's jointly proportional to the square root of B. Okay, well, the square root of B. And notice here, I'm given a capital B, so I'm going to use a capital B. I would not be using a lowercase b. So if you did use a lowercase b, that would get some points docked on your work. So make sure if you're using capitals, if they give you capitals, use a capital. If they give you a lowercase, use a lowercase. All right, so we did jointly proportional to the square root of b and the cube of c. Okay, cube of c is going to look like c cubed. So you might be wondering, should it be the cube root? Well, if it was the cube root, it would say root right there. So it's just going to be the cube of c. We can go ahead and simplify that one to a equals k square root b cube root there. And notice I try to do my little tail. Oh, I didn't do it there. I try to do the little tail on my square root so we don't accidentally think, for example, if I wrote it like this, we don't accidentally think that the c cubed is supposed to be inside. So I put that tail to let me know when my square root ends. So that example, I'll just strike that from the record. Example 3. Write an equation and then solve for the constant of proportionality. So what's the constant of proportionality? That is k, remember? That little guy that's been hanging out randomly? That's what the constant is. So let's first write our equation, which is what we've been doing before. Alright, so y is jointly proportional. Okay, so y is immediately, bam, I put down my constant. Jointly proportional to v and w. Okay, well, v and w. And inversely, okay, so we're going to take the inverse, inversely proportional to z. Alright, there we go. Notice these are all capitals. Alright, let's see. I'll go ahead and let's just multiply these out so it looks a little neater. Alright, so there we go, we have our equation, and then we need to solve for our constant. So we're going to solve for k, which means they're going to give us information for all the other variables. And indeed, they do that. They say if v is 2, okay, so we're going to solve for k. So if v is 2, alright, so we're going to replace the v with a 2. W is 11, so replace the w with 11. And z is 7, replace that with 7. Then y is 10, so let's replace y with 10. Alright, so now we're going to solve for k. Let's multiply both sides by 7. That'll cancel that out. And we have 7 times 10 equals k times 2 times 11. Let's divide both sides by 2 times 11. And let's simplify this side a little bit. I can simplify the 2 and the 5. So then I'm left with 7 times 5, which is going to be 35 over 11 equals k. And since I'm not told to answer in any specific form, as long as this is a simplified fraction, I'll accept that. You could put the decimal if you wanted to. So there right there is my constant of proportionality. Proportionality. That's a big word. Okay. One more page for this section. Oh, there's some short sections this week. All right, here we go, a word problem. So there are 3 steps for variation word problems. I'll go over them as we get to that. Okay, so the drag force on a boat. The drag force on a boat is jointly proportional to the wetted surface area, A, on the whole, and the square of the speed, S, of the boat. A boat experiences a drag force of 220 pounds when traveling at 5 miles per hour with a wetted surface area of 40 feet squared. How fast must a boat be traveling if it has 28 feet squared of wetted surface area and has experienced a drag force of 175 pounds? Whoa, a lot of information. Okay, so the steps that we do. First step, we're going to find the generic formula. Okay, so first off, how do I know this is a variation problem? Best thing is when we see the word jointly proportional. That's a good idea that this is a variation problem. Okay, so finding the generic formula, that's what we were doing in these other examples earlier, right here. So let's go ahead and create that. So the drag force on a boat is jointly proportional to the wetted surface area, A, on the whole, and the square of the speed, S. Well, they don't give me the variable for drag force, so I'm going to say let D be the drag force, since I'm introducing a variable, and then I'm going to use the variables they gave me. So, the drag force is jointly proportional. Well, once I see that, remember, just plop down your constant of proportionality or variation. What happens? It's jointly proportional to the wetted surface area A, okay, so times A, and the square of the speed S. Oh, and that's all that happens there. Okay, so that was our generic formula. Second step, and normally we end up using the second equation, the second sentence. So normally the first sentence gives us a generic formula, and the second sentence will normally give us our specific formula. which means we're going to find k. Or actually, let me rewrite that, solve for k. So that's what we're going to do. Find the specific formula, and we normally end up using the second equation. So it says a boat experiences a drag force of 220 pounds. So the drag force was D, so it says 220 when traveling 5 miles per hour. Okay. So the speed of the boat, S is going to be 5 miles per hour, with a wetted surface area of 40 feet squared. So wetted surface area was A. All right, so I'm going to use this information to find K, just like we did on example 3. Here we go. Let's go ahead and find K. So we're going to use this formula, D equals K A S squared, which we created right up there. Plug in our values so we can solve for K. I'm solving for K. So let's see, 220, 5, and 40. Okay, plugging that into the calculator. K times 1,000. Divide both sides by 1,000 to get K by itself. And we get 0.22 equals K. So there we go, we have found our constant. So my specific formula for our problem is going to be where we plug back in the K. So using this, we're going to plug back in the K, so we get D equals, and the constant for my problem is 0.22, and then AS squared. So now we have finally been able to create the specific formula for my problem, so we can go ahead and solve the application with our specific formula. So third part. Okay, solve app using the specific formula. And normally, the third sentence will give us the information we need and what we're trying to solve for. So let's go back to the top. It's asking, how fast must a boat be traveling if it has 28 feet squared of wetted surface area and has experienced a drag force of 175 pounds? So I'm trying to solve for how fast. That means I'm solving for the speed. And the information I'm given is the wetted surface area, A, is 28. So A equals 28. The drag force, D, is 175. All right, so let's plug that into my equation right here. So the drag force is 175 equals, and then my constant of variation, times my area, 28. And I'm solving for S, so S squared. All right, let's go ahead. I'm going to multiply that 0.22 times the 28. I get 6.16. Go ahead, divide both sides by 6.16. So plugging that in. Oh wait, I think that was it. Yeah, there we go. Okay. Oh no, that was wrong. Let's try this. Third time's the charm. 175 divided by 6.16. There you go, 28.40. And I could round that there, but instead what I'm going to do is I know whatever this answer is, so let me go ahead and extend this. I'm going to take the square root of both sides to solve for s. So square root both sides. Remember the plus or minus. And I'll go ahead and raise my answer to the half power. What do I get? 5.33. So this is going to equal plus or minus 5.33. Now, if I don't tell you how to round, go ahead and round to the hundredths place. 5.33 equals s. I'm going to say it's about that amount. But for our word problem, do I want to take the positive or the negative case? Well, I'm talking about speed. Remember, I'm trying to find the speed, how fast. So I'm not going to take the negative case. Doesn't make sense to have a negative speed. So the answer would be the boat must be traveling 5.33. Ooh, remember we need to write the units. What is this? Miles per hour. Miles per hour. Period. Box my answer. Okay, and there we go. That is it for lecture 1.12. And here's your homework. Due at the end of the week, make sure to email me if you have any questions.